Amides can be hydrolyzed with acid, but it's slow and requires a lot of heat. But at the end of the day, you would get a carboxylic acid plus ammonium. This is similar to the mechanism for hydrolysis of an ester. We can also do this type of hydrolysis under basic condition. They're both slow. We can use lithium aluminum hydride to reduce an amide to an amine. So an H- will attack here. These electrons will attack the aluminum. This is what we saw before with the carboxylic acid mechanism. So we have H, and this is AlH3. That's a good leaving group. So this nitrogen lone pair will come in and kick that off. That's positively charged. And then another H- can come in. And that's how you would reduce the amide. If you have a primary or secondary alkyl halide, you can treat that with cyanide, which can act as a nucleophile in an SN2 reaction. But keep in mind that if you add cyanide to an alkyl halide, that's also adding a carbon, which we saw earlier in the chapter. If you have an amide and you add SOCl2, this will also form the nitrile. This one does not add carbon, so this method adds one C, does not add C's here. If you add acid and heat to a nitrile, this will first go to the amide, which keeps going to the carboxylic acid. If you react a Grignard with a nitrile, we can get that R addition here. We'll get the imine, you add acid to protonate it. We continue here and add acid with more acid and water. This will get converted to the carbonyl. So a Grignard with a nitrile will get you the ketone. So just like we can convert the carboxylic acids to alcohols using lithium aluminum hydride, we can also reduce nitriles to the amines. Alright, so these are all the reactions that you can do with the carboxylic acids and the derivatives of them. And you can go through these individually. So if any of these carboxylic acid derivatives, if you add acid and heat, that's going to get you back to the carboxylic acid. And you can see that the acid chlorides have much more possibilities for reactions and with the acid anhydrides. And as you get to these which are less reactive, you cannot do as many reactions with them. So you can think about different strategies when you're doing synthesis. If you're looking for a carbon-carbon bond forming reaction, think about what functional groups are still there or if they're in the same location. If they're in the same location and you're trying to add multiple carbons and making a tertiary alcohol, you want to think about an acid chloride with Grignard. But if you want that carbonyl back, then you want to think about using the Gilman reagent. If you want to add a carbon to a nitrile, it will attack and then you add acid that will form the ketone. If you have an alkyl halide and you need to add a carbon, you can use a nitrile. You can react it with a nitrile and then make the carboxylic acid. Or if you wanted to add a carbon, you can make it into a Grignard and then do CO2 plus acid to get the carboxylic acid. So if we wanted to do this reaction with the aldehyde, we have the same number of carbons. We can reduce this or hydrolyze it to the carboxylic acid. And then use the bulky lithium reagent in order to get it to go to the aldehyde. When you're doing the new carbon-carbon bonds, you want to make sure you're putting it in the right spot. So if I look here, there's one carbon coming off of there. I'm adding an extra carbon. So I can use the Grignard. And then add CO2 plus acid. And then if I do these reactions here, Grignard I'll draw the intermediates here. So that's the C that was added. Carboxylic acid there. All right, this reaction will not work. So we cannot do an SN2 at a tertiary center. If you wanted to fix it, we could do HCN. And then H plus with water will hydrolyze that acid. All right, this one with NaCN, we're going to invert the stereochemistry to the CN. Here, the PBr is going to swap the OH with a Br. We add the Grignard. CO2 plus water, we'll add a carbon. We'll add that carboxylic acid. SOCl2 is going to make our nitrile. And then we'll reduce it with lithium aluminum hydride to the amine. HCN, that's going to make a cyanohydrin. TBS chloride, that's a protecting group. Then we're going to add a Grignard. That will make a carbonyl with this group here, and then TBAF will deprotect. Okay, if we hydrolyze this, we'll get the carboxylic acid. Alcohol plus acid, we'll do the Fischer esterification. We get methanol. This is going to trans-esterify the ester, which is another reaction that you can do. So we get OMe, 1, 2, 3, and then OH there. And then methanol and acid will make the ester. Dibal will reduce it to the aldehyde. All right, if we want to look at reagents that can do these things here, so I need to do a Friedel-Crafts. To get this put on here, to get it to the carboxylic acid, I want to do an oxidation, KMnO4. And then using SOCl2 plus 2 equivalents of an amine will give this amide. For this one here, I want to add a nitrile with the O that's already there. So to do this reaction, I need HCN. Here I have the OH still intact. A reaction here forms a ketone. So I should protect, use TBS chloride, the Grignard, H plus, and then deprotect. If I want to get rid of this alcohol, I can do a reduction by converting this to a ketone, but I'm going to need to protect this first, so I'm going to use this. This is deceiving that it's only one arrow, but it's actually going to be a couple steps here. So H plus, that will protect it. And then I'll do PCC, reduce it with H2, and then add H plus and water to deprotect. So what that looks like if I do the protection. PCC. You get reduce that, and then it will deprotect to get to the alcohol. All right, and a couple more reactions here. Acid to acid chloride is SOCl2. Here we're going to add one group and get the ketone. So I will add the copper reagent. So this will be ethyl to copper lithium. And then to convert it to a CC, I'm going to use the Wittig, PPH 3.